All right, we are looking at 16 through 18 on last night's homework. Let's start by marking our picture. We always put all the information on the diagram so we can see what's going on. So, VTU is 3x minus 2, SRV is 2x plus 7, and RUV is 2x. Finally, this whole angle is 70. So that was the information we're given. We need to begin by solving for x. That is going to be the key that unlocks all the angles in the whole parallelogram. Now remember, you don't set things equal unless you have a reason. You don't set things equal unless you have a reason. So I can set something equal. I know that this is a parallelogram. So I know that RS is parallel to UT. Therefore, I know by the alternate interior angle theorem that these two angles are congruent. 2x plus 7 is congruent, equal in measure to 3x minus 2. So that's where I'm going to begin. All right, I'm going to subtract 2x from both sides, and I'm going to add 2 to both sides at the same time. Boom, x is 9. Now that I know x, I can plug it in everywhere I see an x. So let me get a new color out. I can plug it in here, 18 degrees. I can use alternate interior angles. I can do 18, 18. 3 times 9 minus 2. So this angle is 25 degrees. 25 degrees. I know this angle is 70. I can do 70 minus 25. Find out that this angle is 45. There's lots of different ways to get at this. I can use alternate interior angles, 45, 45. I know this is one of the angles we're looking for. I can use triangle angle sum theorem, and find that angle. 180 minus 18 minus 45, 117. All right, so that should be enough information on that picture to finish out that problem. I'll let you do that. Let's look at number 21. Let's look at this proof. This is called a flow chart proof. This is new in this unit. We haven't done this before. A flow chart proof has the same information as a two-column proof. It's just the flow of logic. I'm using the word flow because it's a flow chart proof. The flow of logic is a little bit different. All right, you always start with the given and end with the proof. Start with the given and end with the proof. So we are given, oops, that's a B, parallelogram. A, B, C, D. Check. I started with the given. So we know it's a parallelogram. All right, the next one says we need to make a statement, and our reason, our justify, is going to be definition of parallelogram. Well, what is a definition of a parallelogram? Definition of a parallelogram is that opposite sides are parallel. AD is parallel to BC. Check. So I made a statement and my reason was definition of parallelogram. All right. Okay, this next one over here, this showed up yesterday in our notes on one of the proofs. It was something we had never seen in a proof before. It said draw DB. And then the reason we were allowed to draw it is through any 2 points, there's exactly one line. So that's what goes here. This is new to us. Draw DB. So it's already drawn on our picture right there. We have to say that we're drawing it so that we can talk about it later. I like, on ones like this, I like to name the angles and then just use the angles. But if you don't want to name the angles with a number, you can name them with 3 letters, okay? I like to name them with numbers to make our life easier. All right, so in my picture, it depends on what you number them. Angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. This one would differ depending on what you numbered yours. All right, going back to this one, every time we use the reflexive property, we're saying a segment is congruent to itself. Now, which segment would be the most beneficial to say is congruent to itself? Probably the segment that both triangles are sharing. Probably that one. I forgot to mark my angles, sorry. 1 is congruent to 2, double arc, 3 is congruent to double arc 4. Segment DB is congruent to segment DB, reflexive property of congruence. All right, next one. We need to say something, and our reason is angle side angle. Well, angle side angle is only a reason when you're saying two triangles are congruent. So we just need to figure out which two triangles we would want to name congruent. And they're the two triangles that we created when we drew DB. So see, it was essential to draw DB. All right, so triangle BAD, we'll do bad this time, is congruent to triangle DCB by angle, side, angle. See that? Angle, side, angle. I know I'm making my picture really messy. Okay, unfortunately, I'm going to have to clear this to scroll down. Oh, the last one. The reason is corresponding parts of congruent triangles are congruent. What is the statement? I don't even have to guess. I know the statement because we start with the given and we end with the prove. So that goes down there in that last box. I'm not even going to write it. We were trying to prove that opposite sides were congruent. So we were given a parallelogram and we showed that property number 2 was true. Opposite sides are congruent.